Well, hi everyone, and welcome to our webinar today. As you can already see, we have a lot of folks involved in this production, so trust me, you're all in for a real treat. So today, of course, you're all here to watch us talk about debugging your React apps using some very popular inspection and debugging tools, those being a couple of different browser dev tools and Fiddler. And just to set some expectations here, I imagine we're going to be spending about 40 to 50 minutes together today. I know you're all pretty exhausted with the amount of online video content out there these days, so we'll do our best to keep you well entertained throughout. Now, before we kick things off, as usual, if you can't hear me, or maybe you haven't been able to hear me at any time in the last couple of minutes, or at some point in the future, your audio might cut out, please just try connecting to your computer audio, not your phone. This issue comes up often with GoToWebinar. If nothing seems to help, just restart your GoToWebinar viewer and everything should be okay. But if that doesn't work, or maybe you want to rewatch the webinar or share it with someone, you will be receiving a follow-up email with a link directly to the recording on YouTube. We will be sure to send out some links to some of the resources we provide today as well. Now, if you have any questions during the webinar, I did want to remind you that you should definitely let us know. Just use that Q&A panel provided in your GoToWebinar viewer to ask away. If you're on a desktop browser, I believe it is to your right. If you're on mobile, it's there somewhere. We've got plenty of folks here to help answer your questions during the webinar. All right, let me get to introductions so you can put some names to voices today. Let's start with the least important person, and that is me, Rob Lauer. I am a senior manager of developer relations here at Progress. I spend a lot of my time on our Fiddler products these days. Along with me today is TJ Van Tol. TJ is a principal developer advocate and our in-house React expert. And next up after TJ will be Sebastian Vitalis. He is our senior developer advocate. Sebastian's going to be covering some Chrome DevTools best practices and tips and tricks today. And last but certainly not least is our developer engagement manager, Jonathan Pereira. Jonathan will be diving into some key features in Fiddler to help round out our story today. So there are three key components to our webinar today. The first is, of course, the wildly popular React framework from Facebook. And we thought to make our React segment maybe a little more fun, a little more engaging, we're going to utilize Kendo React. This is a really popular native UI and data visualization component library. Now, Kendo React provides a variety of, yes, fully native and very gorgeous React UI and data viz components. Now, the scope of the components provided is quite expansive, and if you'd like to take them for a test drive, you can download Kendo React today at telerik.com/kendo-react-ui. Now, the second big component of our webinar today is, of course, the browser dev tools. Today we'll look at the venerable Chrome DevTools, and TJ is also going to touch on the React Developer Tools. And to round out our app inspection and debugging story is, of course, Fiddler. Today specifically, we are going to focus on Fiddler Everywhere, which is the next generation of Fiddler tooling, built from the ground up using the best of the original Fiddler in a new cross-platform package available for free on Mac, Windows, and Linux. And of course, as I just described all these products, I highly recommend you follow all of them on Twitter. You can find these at Kendo React, Chrome DevTools, and Telerik Fiddler. All right, let's get started for real. I'm guessing most of you already know a bit about React App Dev and maybe enough about your browser dev tools to be dangerous. But if you're new to Fiddler, don't worry, you're not alone. At its core, Fiddler is a powerful desktop tool that allows you to quickly inspect, debug, mock, and save virtually any network request and response. So just think of all the remote API requests your apps make these days. Fiddler can capture, report on, alter, replicate all those requests. And Fiddler has been around for a while. The first version was released more than 15 years ago, if you can believe that. So if Fiddler is this network debugging proxy for really any browser, app, processor, platform, what does that mean in terms of actual use cases? Well, we can start with the obvious, and that is what we're going to cover today in debugging web and network traffic on any device. It also means debugging of remote API calls. But even performance testing of your APIs is possible. Analytics and monitoring can be handled by Fiddler, along with malware analysis and security testing. Now that's a lot for one tool to bite off, but Fiddler does have some really amazing capabilities baked in. And if you're familiar with the old Windows-only version of Fiddler, you may be a little confused by this Fiddler Everywhere thing. Well, over probably the past year or so, maybe a little bit more, we've talked to a lot of Fiddler users to identify what their major issues are with the old version, which we are now calling Fiddler Classic. And we of course learned right away that Fiddler really needs a complete overhaul of its user experience. Gone are the days of the old Windows UIs. And no surprise, but you all aren't on Windows anymore, right? Many of us use macOS or Linux for app development. And finally, many of us are now working on Teams, and the way we diagnose and share sensitive network logs is far different now than when it was 10 or more years ago. So instead of trying to shoehorn these updates into Fiddler Classic, we decided it was time for a fresh start. And we started with a baseline set of features that you've all come to expect from Fiddler Classic. And the first is the Traffic Inspector feature. This allows you to view the details for all network traffic to and from your app. And the autoresponder, this lets you create and modify rules that can customize traffic to test a variety of scenarios. And the API Composer, which lets you see the results of API requests without having to use another tool. So to resolve the first pain point about Fiddler, that being the antiquated UX, we rebuilt Fiddler Everywhere to provide a really modern, engaging developer experience. And point 2, Fiddler now works across Windows, macOS, and Linux platforms. All features are supported equally well across each OS. And point 3, team collaboration. So let me briefly introduce you to the team collaboration features of Fiddler Everywhere. Now by using the team features, you can save captured traffic like you've been doing for years. You can highlight certain saved sessions, add comments to them, and securely share the log files and context with your teammates. So they can open these log files in their copy of Fiddler Everywhere, and you can continue to collaborate from there. So the way it works is very simple. I can click a button to save one or more captured sessions. I provide a name for my saved session. I optionally add some additional information or context to prepare my colleague for what I'm sharing with them. I then click to share this saved session. I can invite my colleagues to then collaborate via a simple email invite. So this allows us to securely view all the same session data within Fiddler Everywhere and without having to share potentially sensitive data in an otherwise awkward or potentially dangerous manner. Now, if you'd like to know more about the team collaboration features of Fiddler Everywhere, just head to bit.ly/fiddler-teams. And while Fiddler is best known as a desktop tool for debugging desktop and web apps, I've got a little secret for you. You can pretty much inspect network traffic on any app or device that supports a network proxy. And you can, of course, grab your copy of Fiddler Everywhere at telerik.com/fiddler and try it for yourself. All right, that's enough of me blabbing at you. Time for the real experts. First up, I'd like to invite TJ Van Tol onto the virtual stage. TJ, why don't you take it away?
All right, thanks, Rob, and thanks everyone for joining us here today. My name is TJ Van Tol, and I work as a developer advocate here at Progress. And today, I've got 3 different topics to cover for you. Now, this is a debugging webinar, but in order to debug, you need an app first. So we'll spend a brief bit of time starting up a little starter app that can help us perform these debugging tasks later on. And to make that process go fast, we'll be using Kendo React, a premium set of UI components that we make here at Progress that's just going to help us get this app up and running quickly. And once we have that app running, we're going to spend the bulk of our time looking at the React Developer Tools, which is a free-to-use browser extension available for both Chrome and Firefox. And after that, I'll turn things over to my colleagues Sebastian and Jonathan to keep the debugging train rolling with this application. And all right, step 1 is to build an app. And for that app, we're going to be building a financial dashboard for my personal favorite fictitious company, Acme. And you'll see that there's quite a bit going on in this application. So I actually want to dive right in and switch over to my development environment so that we can get started. And over here, you'll see that I actually already have a pretty good start on this app just to save us a bit of time. So this app already includes a few Kendo React components, like the drawer that I'm using for navigation. Got a panel bar for showing some information about this fictitious mutual fund on this left-hand side of the page. And I've got a Kendo React chart to show some asset allocation, busting out some financial terms today for this fake company. Now, what we're going to do to kick this webinar off together here is we're going to add 2 more Kendo React components. You'll see there's 2 sort of open slots here and here, so that you can get a quick sense of how Kendo React works and also get familiar with this code base that we're going to be using throughout the webinar. In my editor, you'll see that this app has a panels folder, and each panel is essentially a section of this dashboard page, where we currently have 2 of these implemented and 2 that are not. Let's implement this performance panel first. And when I'll go in here, you'll see this file is relatively empty, but I do have a call out to a backend that's fetching some data for me and that we'll be using later on in this webinar as well. But for now, our goal is UI and components. And for this performance pane, I want to add a second Kendo React chart. Now, adding any Kendo React component is a simple 3-step process. Now, first, you have to install that component from npm. And I've actually already done this. We got the chart somewhere in here to save us a bit of time, so you don't need to watch me npm install something. Each component is modular so that you ship only the code that you're using to your users. And with the package installed, the next step is to import that component, which I'll do up here. And then to head down here and use that component in my JSX. And when I do that, you see that this app refreshes, and we have a pretty decent looking chart. I went with a line chart for this data that we wrote in 8 or 9 lines of code there. And then we also get a chart that matches the look of the rest of our components and this application, minus this pink that you see here, which Sebastian is going to be addressing later on here. The appeal of Kendo React is not only can you build some of these components really quickly, but that you can customize them in many different ways as well. So if you wanted to learn more about the chart, for instance, you could head to kendoreact.com, head to the docs and demos section. You'll see all of the components listed here. There's quite a few of them. The charts is one of our most popular ones, so it's highlighted here on top. And just sort of browsing around, you can get a sense of just all the things you can do. There's something like 12 different chart types that you can build, and you can add a bunch of features like adding labels or legends or crosshairs or many other things to your chart as well. All right, so that's one component. Let's add one more just so that we can finish this app up and so you can get a sense of how this workflow works. And for that, so that's the performance panel. This positions panel is the last of these that is currently empty. You'll see I have the same basic workflow here where I'm just getting some data from a backend and setting it available. And for the implementation of this data, I actually want to use the Kendo React grid, as it's the most popular component we have in Kendo React. So like before, I've already got the grid installed. It's somewhere here. Yep, there we go. So that part is ready to go. So once again, all I need to do is import the appropriate APIs, and then I'm going to use that grid in my JSX. And for this example, I'm using one new feature of Kendo React, and that's our custom rendering option. The idea here is that Kendo React, we realize that developers basically need to customize just about anything about the components that they use. And as such, we provide a lot of different extensibility APIs, especially for our more complex components for things like charts and grids. So in this case, what I'm saying is to render the actual cells of these grids, which we'll see in a second, I'm going to use a handful of, well, 2 different custom components. So I'll go ahead and paste these in and save them so that you can get a sense of what they look like. And specifically what I wanted to do is add a little bit of logic for these cells down here, these change and change percentage columns, so that I applied a different class name based off the value. So positive values show up in green, negative values show up on red, a pretty common thing that you'd need to do in really any sort of financial app. And the second thing I'm using for extensibility is this number cell, which is going to let me do a little bit of formatting on these large numbers that come back for things like volume and market cap. Now, I'll once again point out that on the Kendo React docs, if you go to docs and demos and data grid, you can find a lot more of what the grid can do and what the components can do in general. But for the grid specifically, there are quite literally dozens of features, from editing, filtering, grouping, paging, sorting. You can even do things like Excel exporting as well. And we'll actually use two of these features here later on. But this is a debugging webinar, and you might have noticed as I scroll down here that actually a handful of these grid cells are currently empty, which is going to be a very seamless segue into looking into the React Developer Tools. And I want to figure out what happened, what I did wrong in my logic that these cells are empty. And to do that, I want to introduce you to the React Developer Tools, which are available for both Firefox and for Chrome. I'm in Chrome, and I've already installed the React Developer Tools. You can find these in the Chrome web store. So that's chrome.google.com/web store. I think you can also get there from this extensions icon up here. And once you have this installed, the first sort of feature of this extension is that it detects when React is active on a page. So this icon up here will turn red when it detects the development version of React, which is what we're using in this sample, and black, or sort of the default logo of React, when it detects the production version of React, which can be just kind of a fun thing if you're just browsing the web and are curious, like Airbnb, for example, uses React. If you're just sort of curious which sites use React and which don't, it's just sort of a fun thing to have up in the top corner of your browser. The other thing the extension gives you is two new tabs in the React Developer Tools, and that's a Components tab and a Profiler tab. The Components tab is somewhat similar to the Chrome DevTools Elements tab, in that it shows you a tree representation of your app. But the key difference is that the Components tab is showing you your React component tree, rather than the DOM tree that the browser renders. There are a few little tricks you can do on this tab to make navigating around a bit easier. First of all, as you hover on items in the Components tab, you can notice how Chrome highlights them for you on the page. So for example, this button corresponds to this button here in the top corner. You can also use this inspector here to inspect an element on the page and head straight into where that element appears in the component tree. This tree can also get quite complex. There can be quite a few components, especially in real-world-ish apps. So another thing you can do is double-click on an individual component to zoom in on it. So you can go into the grid row, go around to the grid cell, and you can also use this X to sort of clear these filters completely out and get back to the default view. Over here on the right-hand side, you can see details about each individual component and perform a few actions on them. For example, I find this little eye, I think that's an eye icon, kind of handy, as it lets you switch over to the Elements tab with the appropriate or the corresponding HTML element for that component already selected. As I do find it's pretty common for me to jump back and forth between the React-specific stuff in the Components tab and what the browser actually renders in the Components tab. And if I head back to Components, I also find this little view source icon pretty handy as well. So for example, if I took let's take the number cell here and click this icon, you'll see it acts as a shortcut to the Sources tab and automatically highlights or just takes me to the spot where that component is defined in my code, which can be super handy if I wanted to, say, quickly set up some breakpoints to step debug to see what was happening within this component. Finally, for each component, you get a handy way of viewing that component's props. And you can change them inline as well. So if I wanted, let's take snap here. And if I inspected this and I go into the data item, and somewhere here I'll find the name, the symbol here. So I could change this to some other value, and you can see that it updates in the DOM right away as well. And these props are actually going to help us debug this empty volume cell issue. So if I use this inspector again to grab this completely empty cell, and I go down in my props, remember that the volume is actually what I'm rendering here. And if I go down to the props here and find the volume that actually comes back from the backend, you'll see that I am getting a value here. And for whatever reason, that value isn't actually rendered in the DOM at all. If I switch back to my code, the problem was fairly easy for me to spot when I first did screw this up in this sample. If this component gets a volume that is over 1 million or over 1 billion, there's a bit of code here to do some custom formatting and such. But if the value is under 1 million, this uninitialized value is just going to be returned verbatim. Now, I could do some fancier logic here, but one small thing I can do to fix this problem for now is just initialize the value I'm going to return with the value that comes back from my API. And when I do that, you'll see that these cells that were previously empty now have a value in them. And how I was able to sort of track these issues down, or at least get a sense of what the problem might be, by using the Components tab, finding the props of the problematic component, and using that as sort of a first step to debugging what the issue was. And really, the specifics of the implementation aren't really that relevant here, as all I wanted to do is highlight how easy the React Developers tools make this workflow. Inspect your components, see the props, maybe dive into the code and set a breakpoint, and ultimately find and fix the bugs in your code. So that's the components pane, but before I wrap up today, I also want to give you a brief walkthrough of the profiler pane, as I find it's a fairly handy way to find potential performance issues in your React apps. Now, the main way you'll want to use this is to hit this record button on the left side, and then do some things in your app. So maybe I'll navigate to this home page and back again and go ahead and stop that. And this is going to render what's called a flame graph, which shows you how often your components render and also how long they take to render. And what makes this visualization particularly useful is it highlights the actions that take the longest amount of time. And because of that, the easiest way to use this tab tends to be to make a recording, find the sort of biggest bars, and figure out what's going on in them. And actually, there's not much of an issue here, because even some of these longer bars you'll see are rendering in something like 13 milliseconds, which isn't really a huge amount of time. So to make this a little bit easier, I'm going to introduce a performance problem into my app to make this sort of stick out a little bit. So let's head back to this positions panel, which is again rendering this grid down here. And what I'm going to do is find this bit of code that gets the data from the backend. And I'm going to say, well, all right, instead of just using that data, go ahead and duplicate that data 500 times and then set it as the data set that this grid should use. And when I refresh this, you'll see that my browser is already chugging, trying to deal with this. And it manages to do it, but I'm not sure how good it'll come through on the webinar, but everything is already sluggish, scrolling, moving around this application. So if we go to profile this app again, let's go ahead and discard this current set of profiling data, and we'll record this again, and we'll see I can't even, okay, I did manage to get off of this. I'll render this. Let's go back to this is really chugging, but I have confidence. I have confidence in Chrome to manage this. So we'll head back to this page, and you'll see this grid is really, really chugging. It's really, really thinking about it, as this is now a data set that's, I think it's something like 15,000 rows for it to render. So it does it, but if we look at our actual performance graph here, and there we go, the bar was kind of hidden at the end, you'll see that there is a render of the Kendo React grid. Now you'll see that this grid renders 2 different times. And in this case, this is actually expected. Because of the way I'm implementing this, the grid is going to get rendered 1 time without any data, and then a second time when this data comes back from the backend. Now, if you're seeing renders in this tool that you don't expect, that's something that you could also look into your code to see why this is happening. But the problem in this case is you'll see the first render took about 20 milliseconds, which is totally fine and good. And the second render took almost 3 full seconds because it's dealing with an absolute enormous amount of data. Now, knowing how to actually address these performance problems can be tricky, as each scenario is sort of different and depends on your application. Now, in this case, I happen to know that the problem is the grid is rendering a table with something like 15,000 rows of code. And browsers are just not well equipped to handle this and tend to have memory and just performance issues in general when they run into this situation. So for this specific scenario, I'm going to paste in a slightly different implementation of this grid that's using the same data set, but it's using a feature of the Kendo React grid called virtual scrolling, which is going to, again, use that same data set, but sort of intelligently reuse about 20 or so rows from the DOM and reuse those elements to avoid these sort of performance issues. So with this new implementation, I'll again reject this current profiler view, and I'll start profiling again. I'll do the same sort of steps where I go home, and back to the tech fund page. You'll see that this renders, the grid is there. We'll go ahead and turn the scrolling off. And when I head back to the grid, actually it takes me a second to find it now because you'll see I have those same two renders, but now the first render and the second render is down from 3 seconds to about 14 milliseconds. And you can also see how visually, when I go and scroll this too, how this is significantly more performant and doesn't slow down my browser in general. Now, overall, the Profiler tab is just a great way to track down performance issues in your app. So if you do notice something sluggish in your React apps, or maybe if your users are reporting something that's slowing down when they use it, or if they perform certain actions, what you want to do is head to this Profiler tab, record and perform those actions, and just note which are the sort of problematic areas that you need to track down and address. And if you combine this with the Components tab, you have a pretty nice set of tools for debugging the React apps that you build. The last thing I'll note before tossing things over to Sebastian is that if you want to learn more about the Kenda React components I use today, or try them out for yourself, go ahead and head to kendareact.com and sign up for a free trial. All Kenda React trials include full access to our 80+ UI components for 30 days, as well as full access to our world-class support resources. Now, our debugging journey is still just beginning, and I guarantee you there are still plenty of issues in our Acme sample app to tackle. So at this point, I'm going to toss things over to Sebastian, and he's going to be covering a bunch of the other features in the Chrome DevTools.
All right, TJ, this was pretty amazing, and I really enjoyed that. And now I know how to build a React application. My name is Sebastian Vitales. I'm a senior developer advocate at Progress. You can follow me on Twitter at Sebawita. So I want to take it from here and basically talk to you a little bit about Google Chrome Developer Tools and how you can use it to improve your web applications. And in general, I will give you some web dev tips and tricks. So the first thing I want to start with is the shadow editor in Chrome. And this is really cool because I can go to the website and see what's going on in here. And this pink shadow doesn't look quite great. So I can go here and inspect it. And I can make some changes. So for example, straight away, we have this box shadow here. So I can click just here and say, okay, I'm going to move it a little bit down. Let's put it about here. Let's add a bit of blurriness. Let's reduce the spread. And maybe we can also change the color. So I'll go to Carl and change color from his background. And we already have this style here. And I can go to the project and find the style that we need to update. So this is our box shadow. Okay, so that's number one. And we also have to have a look at this text shadow. So let's have a look. So the text shadow exists directly on the manager. And we could also change this a little bit. So again, let's move it a few pixels up and down and then add some blurriness. And again, I'm gonna steal the shadow from Carl, but you could basically pick anything. So just like this, copy this, go to the project, paste it here, and now our project will be updated. So every time I reload, we'll already have those pretty shadows. Next thing I wanna show you is the design mode that is built into Chrome. And that allows you to actually edit the website as if it was a document. So I can, for example, open the console and say something like document design mode on. And let's play this. And I can, for example, say something like asset stock location, all font performance, or I could change Nora's name and say has an extra name. Ooh, and you could already see that there's something going on here, and the styling is not designed to handle longer names. So why don't we go and fix it? So maybe we could just go to the manager and add a quick display grid. And then next thing we should probably is just set like a grid template columns. And I could say, okay, I'm gonna have a photo column which will be, let's say 70 pixels wide. And then there will be details, and details will take all the rest of the available space. So next thing, let's get rid of the display on the manager image. And this one basically will use the grid column, and this is photo. While the manager info, we're not gonna use any of this. And this will be grid column details. All right, let's save this and go to our web page. So now you can see Nora has an extra name, fits really nicely into the content. So that worked pretty nicely. And we could basically go around and make all sort of changes and just see how CSS reacts to that. Another thing that we can do in Chrome is use Network Inspector to see what is going on, what sort of network traffic we get, and look for various optimizations. And as part of that, I also want to show you how you can shrink fonts and basically request only the characters that you need. Let's go back here. So we can change here and then go to the network tab, and you can see there's a lot going on, right, when we load a web page. So we could see direct web service calls, we could see what JavaScript we're loading, what CSS we are loading, maybe what fonts and images. So I want to have a look quickly at the fonts, and you can see these two are for /s Ubuntu, and it's this one too. And those are basically 28 kilobytes altogether, and they're only used just in here. So what I can do to fix that, there is a trick. So to reduce that, what I can do is go to the project, and then in the index.html where I'm loading the fonts, I can add some additional parameters. So I can say add end text equals Acme stocks. We also have home and tech fun. And in general, this is all about listing all characters that we want to get from these fonts. And when I save this, I can go back and you can see the fonts get loaded, and we are only requesting about 2 and 2 kilobytes of each. So we are already saving on some of the bandwidth. And this can get a little bit tricky when you want to debug, when you forget some characters or you add some new titles. So be very careful with this, but overall, this is a pretty neat trick. So the next few tricks is around using the Lighthouse, the built-in feature that gives you a score for the website in terms of how well it is designed, how well it would be performing when it comes to loading on various devices. And that also gives you a list of available opportunities for improvements to not only improve the score, but basically improve the performance of your website. So as part of this, we'll be focusing on image optimization. One of the first optimizations that you should always consider is properly sizing your images. So instead of serving like a 1 megabyte image, you should be looking at serving something that is exactly at the resolution, that is exactly for the resolution that you'll be displaying it to the user. And we also probably should be looking at using responsive images. So don't have just one image for one resolution, but potentially have 2 or 3. So maybe we could have one resolution that is designed for web and another that is designed for mobile. And then you can serve it at the size that is required, and then use media queries to load those images. So let me go back to the website, and I'll, for example, go to the home page. And then from here, I will choose the Lighthouse, and we'll run the test for performance, best practices, and let's see how it looks on mobile. So Lighthouse just auditing my website, and then we'll get some score, and then it's like, oh, just 53 on performance, 100 on best practices. Well, one part of it is going to be down that is just running in a debug mode. So we definitely should be using a full build, but also if you have any extensions like Grammarly and other things, then that could affect overall performance of what you are testing. So it is also advised that you are testing Lighthouse in the anonymous mode. So for example, I can copy this, open anonymous, drop it here. And if I go to inspect Lighthouse, run it one more time, the score might be a little bit better because there are no Chrome extensions that would potentially be affecting the outcome. So yep, we are getting 55. So one of the things that we can see is immediately Lighthouse tells us a whole lot of things that we could do to improve, like remove some unused JavaScript, serve images in next-gen formats, or properly size them. If I click in here, it is telling me that I should probably resize TJ's head, but mostly this finance chart image that is here, it's way too big. There's like over 1 MB, and we could save pretty much most of it. So let's have a look. I'm going back to the project, and I already have two images prepared that are at two different resolutions, just like I mentioned before. And I'll add it to my public folder, and now we can start playing and changing it. So I'll go to the home TSX, that's where the image is, and we'll be making the necessary changes. So what we should probably be using is a picture tag, and then inside I'm going to put this image. And what we also want to do is add a source and basically point that source at our images. So I'm going to set this one first on the finance chart, and I want to load the 600 JPEG file. And then also I want to add a media query, right? So I want to load this image only when the max width is up to 600 pixels. So this is going to be for small screens. For larger screens, I'm just going to use min width and then serve the 1200 JPEG. And basically, this is our fallback, and also the definition where we provide additional styling or alternative text, etc., etc. So by doing that, I should be able to go back to our web page, and I'll just work now from the network tab just to see what's happening. So going back to images, reload, and now the finance chart is 120 kilobytes, which is a lot better. And I can also toggle the screen to mobile version, which loads a slightly different picture, and this one is 40 kilobytes. So we are straight away getting some savings, which is great. But just resizing images is not enough. We should also be serving those images in the next generation formats that are designed for websites. And you could shrink easily those images by even a quarter or if not more, and then basically serve them as .webp files, which is really, really cool. And in case if you don't know how to do that, there is a special tool which is called WebP CLI, and you can read more about it at Google developers site. And to install it, if you have Homebrew, you could just call brew install WebP, and all you have to do after that is just run commands like this, where you say cwebp-q, set the quality, say what file you want to override, then do -o, and then give a path and the name of the file that you want to generate. And then one other thing that you should also consider, especially when you have images that are off screen and they don't necessarily appear immediately, you should use lazy loaded images. And you could do that by just adding load equals lazy to your images, and that's it. So now let me show you how to actually do this. So I'm gonna open the command line and use the WebP tool. So call cwebp-q50, and we are going to public finance chart, and we'll do first the 1200 JPEG -o, and we'll basically follow the same routine, finance chart -1200, but this is going to be called WebP, and that straight away generates a new file. And then we can do it again for our 600, and that does the trick. We are now seeing two additional files. So we have the WebP 600 and 1200. In case you have loads of files that you want to optimize, you could actually run a little bit of a script. So you could say, for file in this folder, go and run this, and then generate this file with .webp at the end. And when I run this, you could see like we are getting a new WebP file for each phase, so I could then go on and change it really quickly. So I'll just use it on this example. So in order to use the WebP files, what we have to do is just set the type to image slash WebP, and we are just gonna do it for both images. And I'm gonna rename the file now to use the correct extension. And what this will do is when we load this page, the browser will first try to load the WebP file. So if you're in Chrome on Firefox, it will straight away work. But if you're in some older browser that is not compatible with WebP files, then it will fall back to the default large finalschart.jpg. So we could probably just reload this. And now when I reload the page, you can see we are loading the WebP file, which is less than 8 kilobytes, which is pretty impressive because that's a lot bigger file than TJ's had over here, and it's well optimized. And then finally, we say loading equals lazy. That will also make sure that the images that don't appear immediately won't necessarily get loaded until they're needed or until there is available bandwidth. Okay, so after the image optimization, maybe we can still have a look at the other page and see what's happening. And oh, what's this? It looks like, oh, something's not loading. Let's check my web services tab. Oh, there's an error with the allocation. And it looks like I've run out the hourly limit of the calls to my API. So I guess that's all that I'll be able to show you with the optimizations and what sort of things you can do in Chrome DevTools. And this is probably a good moment for me to hand over the microphone to Jonathan, who I'm sure will have a good idea on how to work around the issue that I just hit. So thank you for listening, and over to you, Jonathan.
Thank you, Sebastian. Hi everyone, I'm Jonathan, and I'm going to be spending a couple of moments talking about some of the issues that Sebastian highlighted regarding the Chrome DevTools. Now, I gotta give it to you that I'm personally a huge fan of the Chrome DevTools, and I like how handy it can be when you want to quickly test some of the network requests or figure out some of the problems with the websites. But at the same time, Chrome DevTools definitely does have its set of limitations, which might not be great if you are a tester or if you want to debug something professionally. For starters, the Chrome DevTools have a set of limitations in terms of the usage. So if you are a developer or you are testing a website which makes a lot of network requests continuously, then Chrome DevTools might not be the ideal option for you. The next problem is rather interesting. Of late, all the startups and enterprises have migrated to cloud-based SaaS platforms like Amazon AWS, Google Cloud, or Microsoft Azure. And these platforms tend to use usage-based billing, which means you are required to pay for only the amount of data that your project uses. While this sounds good, think about the problems that this can cause. Because a simple mistake in the API request code can cost you thousands of dollars. And this is exactly what happened to a crowdfunding app based in Colombia a year back. One day, they just received a bill of $30,000 from Google Firebase. And this was because they had made a very simple mistake in their application. Turns out the application sent more than 40 billion requests to Firestore in less than 72 hours. An immensely costly mistake for the company. The primary reason this happened was because while they were testing the application, the network calls and all the data transfer was getting charged. And this cost the company $30,000. So a simple mistake like that can cost you a lot. The other thing wherein the Chrome DevTools becomes really unhelpful is in a scenario wherein you do not have the backend ready, or maybe you do not want to test on a live server or the one which is already in production. In that case, it becomes really difficult and Chrome DevTools is literally useless. So the big question here now is, what's the solution to this? Enter Fiddler Everywhere. What is Fiddler Everywhere, you might be asking? Let me tell you. Fiddler Everywhere is simply a network debugging proxy tool that works with any browser, desktop app, process, or platform. Fiddler Everywhere can be used to inspect, debug, mock, and share network requests and responses on any device which supports a proxy. So every request you make whenever you open a web page in any browser, be it on your desktop or mobile, Fiddler Everywhere can capture it, inspect it, and even modify it for you. Now let's see how Fiddler Everywhere can help us with the situation that Sebastian presented us with. I have opened up the Acme Stocks page on my Chrome browser, and at the same time I have opened up the Fiddler Everywhere tool. I'm going to toggle on the live traffic and let it start capturing the traffic coming in. And let's refresh the page. So you would notice that Fiddler Everywhere starts capturing all the requests coming in from Acme Stocks page. At a glance, you could quickly see the type of content returned. For example, JSON, we have a font file, we have an image file, as well as the status code and the protocol in which the response was received. Other things like the host server URL along with the page URL and the method that was employed, the size of the body, and the content type. So I can click on any of these network sessions and the traffic inspectors will open up. When I click on the tech fund page, I can see the traffic inspectors open up, wherein I can see the request headers as well as the response headers. If I click on text, I would be able to see the entire HTML that has been returned by the website. You can also see all the other requests that have come from this website recorded and captured by Fiddler Everywhere. Coming to the problem at hand, if you want to test this website without having to continuously ping the server, then Fiddler Everywhere has the ultimate option for you, and that is the autoresponder. Now, the autoresponder is basically Fiddler's way of mocking the response and providing it to you every time you request it without actually contacting the server. Every request that you make that matches the condition, Fiddler Everywhere will return the response that you have mocked using the autoresponder. But before we get into mocking a response, let us first test the APIs and see how they work. We'll pick up the performance API, which would provide this graph. Now, Fiddler Everywhere also has a feature called the composer, which allows you to test and create new requests. So we are going to copy this request and go to the composer. Now I'm going to paste the URL in the composer bar, set the method to get, and hit the execute button. You will notice that it will return a 200 OK status, which means the response was successful. Now, if we go to the JSON tab, you would notice all the responses are provided right here. And this are exactly what we see in the graph. Now that we checked what the server provides for this request, let's go back to the traffic and let's create a rule to mock this particular request. To do that, you simply have to right click on the request and click on add a new rule. The new rule tab will open up in the autoresponder and a rule will be automatically added. You need to click on the edit button, which will then provide the match criteria. In this case, for every exact match of this particular URL, autoresponder is going to perform this particular action that we mentioned in the action tab. Now this could be anything. It could be something like setting up a delay or redirecting. But for now, what we are going to do is modify this numbers. So I'm going to change the value of 2018 from 22,181 to 16,110. So autoresponder allows you to manually change the response of any request and save it right there and then. So I save it and I refresh this. The moment I refresh my page, you would notice this graph has automatically changed. Now what is happening is autoresponder is providing a response every time I fetch this particular URL, which means this is now being served locally without contacting the server. For all practical purposes, the server doesn't even know that we are currently making this particular call. The other way to do this is autoresponder also allows you to directly provide a file which can be used as a source. For that, all I'm going to do is in the action, instead of providing a manual response, I'm going to provide the path of the file which is on my desktop. And I'm going to save this rule. Now, if I reload this page, you will notice that this graph has entirely changed. That's because now it's fetching the values from the file which I have saved on my desktop. Those are some of the interesting things that you can do with autoresponder. And keep in mind, you can keep making this request 1,000 times, 1,000,000 times, or 1,000,000,000 times, and it's not going to make any difference to the server. And Fiddler Everywhere definitely doesn't have any problem whatsoever. The other thing that autoresponder can be used for is to debug the files that you're using within your website. So for example, let's say we want to replace the profile icon that this website is using. All I need to do is find the request for that particular image, which seems to be here because it does say profile image, but let's double check just to make sure. I'm going to go to the inspectors and open up the image inspector. And sure enough, that's the same profile image. Now what I'm going to do is I'm going to create a new rule on this, which says every time this image is being fetched, instead return an image which is on my desktop, for which the path I will provide in the action bar. All right, and I save this rule. Let's reload this page and see what happens. Sure enough, now the profile image is replaced with my photo. Sorry TJ, this is now mine. Alright, so these are some of the cool tricks that you could use Fiddler Everywhere for, and this especially is really helpful if you plan on debugging requests repeatedly and continuously. Now that we saw how you can use Fiddler Everywhere for testing your network requests, let's see what other capabilities Fiddler Everywhere has. So this tool can be used for multiple functions. However, it is primarily used to debug web, desktop, and mobile applications. For example, identifying the missing files or code lines causing the web page to be displayed wrongly. But apart from this, it can also be used to test APIs, especially for authentication and HTTP status codes. Another interesting use of Fiddler Everywhere is in security testing, where it can be used to inspect and manage web sessions and even check for cross-site scripting vulnerabilities. Fiddler Everywhere can also be used for performance testing to carry out load tests and even simulate bandwidth and latency tests. Other uses include in malware analysis and analytics debugging. We have made sure that Fiddler Everywhere is widely available and supports Windows, macOS, and Linux. And it has some very interesting features which help you collaborate within your team. So if you still haven't downloaded Fiddler Everywhere yet, head over to the telerik.com/fiddler page and download it now. It is free to try. Now, let me hand it over to Rob, who will tell you how you can use Fiddler Everywhere remotely. Over to you, Rob.
Awesome. Thank you, TJ. Thank you, Sebastian. And thank you, Jonathan. Great work, guys, as always. Now, before we wind down today, you do get me again. And I do have the proverbial one more thing for you all. And that has to do with the reality that remotely debugging issues you receive from customers is not easy. This is no surprise to any of us, I'm sure. You're relying on both technical and non-technical users to be able to convey what can be a very detailed problem with very little context, and oftentimes no technical logs or information to really help you out. And to really diagnose these issues, frankly, it's not easy for customers to even submit their network log files, especially for those non-technical folks. And, they're worried about privacy and security of their data. Support teams, they waste a ton of time with that back and forth between them and the customers. Just collecting log files is pretty much like pulling teeth, and there are often internal compliance and security issues they also need to work around. Finally, us developers, we don't have much to go on due to that lack of information and maybe inability to replicate issues with the info that we have on hand. Well, I'm pretty excited saying that in the next few weeks or so, you're going to have a chance to experience our way of solving this problem. That is with a brand new product called Fiddler Jam. And at the risk of reading text off a slide, I can tell you now that Fiddler Jam is a solution for support and dev teams to help them troubleshoot issues in a fast, easy, and secure manner. Well, what does that mean? Let me play my very quick demo of the Fiddler Jam workflow here so you can see for yourself how we will help to solve this problem. For this demo, I'm going to use a simple to-do web app. So wearing my end user hat, I'm going to type in buy milk and click submit. And right away I get an error which notifies me that the item cannot be added. Well, that's no good. After consulting with the support team, they've directed me to use the Fiddler Jam Chrome extension to record network logs while reproducing the issue. Then I can securely send them the logs for further analysis. Let's see how this is done. Now I already have the Chrome extension installed, so I open it by clicking on the icon. The UI is pretty simple, letting non-technical users record and submit issues with a minimal interface. So I can click to start capturing log files, reproduce the issue in my browser, then stop capture to obviously stop capture of the logs. There's also an option to capture screenshots on clicks, so every time I click my mouse, a screenshot will be saved along with the log files. So let's turn that on and start recording. Now that recording is started, I'm going to want to try and reproduce that issue. Let's add buy milk again, and this time it works. Well, it's interesting. Let's try buy bread instead. Now we get the error. Now since that error was recorded, let's stop the capture and share these log files with the support team. Once I click on stop, I'll have the option to view the log details captured. A more technical end user may want to see this. But let's hide those details for now and share the captured sessions. Next, we have this option to set password protection. This will secure and encrypt our log files with the supplied password. So let's enter a password, my email address, and a description to save the logs. Now I can save everything in the cloud and submit the saved logs to the support team. Since I added a password, the logs will be encrypted and everything will be securely saved in cloud storage. And as soon as that upload is complete, a link will be generated and can be manually shared with the support team. Now, switching hats and acting as a support person, I can open the provided URL in my browser, which will take me to the web dashboard. Let's enter the password from the end user here. And once the password is entered, the log file is then decrypted and displayed in the browser. Now, the log file contains all the requests and responses that were captured while the end user was replicating that issue. On the left of our view, we see all those request URLs, and on the right, we see the request details and the response details for individual requests. On this one, we can see where a to-do item endpoint failed. I can click on the item to see the details. In the response headers, I'm seeing an internal server error. Well, that likely caused the initial problem. I can also see the screenshot of exactly when that error occurred, giving me even more context and a visual representation of the state of the application at that time. Now I can also add comments to the requests to add additional context for the development team, who will next be looking at the issue. In this case, I'll add a comment on the issue that failed, describing it in some more detail. Now that the support team is done and has triaged the issue, I can then move on to the dev team for further analysis. Again, switching my hats, as the developer team, I can use the web portal to view some details about the request, including the screenshots, just like the support team did. Let's open the failed request again and look at any comments that were added. Now, most importantly, I can then open the captured logs in Fiddler Everywhere to do further analysis, such as replaying the captured session to test the scenario in action. I can also test the behavior of the remote API with the exact parameters used when that request failed. I can also create auto-responding rules to mock the responses and simulate any issues the customer may have experienced. So in the last few minutes, we covered all three user scenarios, from the end user's experience of capturing the details of the error through to the support team and how they quickly triaged the issue, finally to the developer and how we viewed the comments and loaded the sessions directly into Fiddler Everywhere to further diagnose and debug. So hopefully that made sense and hit on some pain points you may be experiencing today. If your curiosity is piqued, you can learn a little more about Fiddler Jam and sign up for our pilot program at telerik.com/fiddler-jam. And that is it. Thank you all so much for attending. For next steps, I recommend you download Fiddler Everywhere today at telerik.com/fiddler and take it for a spin. Take a look at what's coming from the Fiddler family in remote network debugging with Fiddler Jam. Sign up for our pilot program right now at telerik.com/fiddler-jam. Finally, be sure to grab a copy of Kendo React at telerik.com/kendo-react-ui. So that is it from all of us. Thanks again and have a great rest of your day.